USB on the go, often abbreviated to USB OTG or just OTG, is a specification first used in late 2001, that allows USB devices such as digital audio players or mobile phones to act as a host, allowing other USB devices like a USB flash drive, digital camera, mouse, or keyboard to be attached to them. Use of USB OTG allows these devices to switch back and forth between the roles of host and client devices. For instance, a mobile phone may read from removable media as the host device, or present itself as a USB mass storage device when connected to a host computer. In other words, USB on the go introduces the concept that a device can perform both the master and slave role as whenever two USB devices are connected and one of them is a USB on the go device, they establish a communications link. Whichever device controls that link is called the master or host, while the other is called the slave or peripheral. Overview: Standard USB uses a master-slave architecture. A host acts as the master device for the entire bus, and a USB device acts as the slave. Devices are designed from the start to act in one role or the other. Computers are generally set up to be hosts, while printers are normally slaves. When a device is plugged into the USB bus, the master device, or host, sets up communications with the device and handles service provisioning. The host is responsible for all data transfers over the bus, with the devices only able to signal that they require attention. To transfer data between two devices, from a phone to a printer for instance, the host first reads the data from one device then writes it to the other. This allows the devices to be greatly simplified compared to the host. A mouse, for instance, contains very little logic and relies on the host to do almost all of the work. While the master-slave arrangement works for some devices, there are many devices that might want to act as a master or a slave depending on who else shares the bus. For instance, a computer printer is normally a slave device, but when a USB flash drive of images is plugged into the USB port of the printer with no computer present, it would be useful for the printer to take on the role of host, allowing it to communicate with the flash drive directly and print images from it. USB on the go introduces the concept that a device can perform both the master and slave roles, and so subtly changes the terminology. With OTG, a device can be either a host when acting as the link master, or a peripheral when acting as the link slave. The choice of whether to be host or peripheral is handled entirely by which end of the cable the device is plugged into. The device connected to the A end of the cable at startup, known as the A device, acts as the default host, while the B end acts as the default peripheral, known as the B device. After initial startup, setup for the bus operates as it does with the normal USB standard, with the A device setting up the B device and managing all communications. However, when that same A device is plugged into another USB system, or a dedicated host becomes available, it may become a slave. USB on the go does not preclude using a USB hub, but it describes host-peripheral role swapping only for the case of a one-to-one connection where two OTG devices are directly connected. Role swapping does not work through a standard hub, as one device will act as the host and the other as the peripheral until they are disconnected. Specifications: USB OTG is a part of a supplement to the Universal Serial Bus 2.0 specification originally agreed upon in late 2001 and later revised. The latest version of this supplement also defines behavior for an embedded host which has targeted abilities in the same USB standard A port used by PCs. Superspeed OTG devices, embedded hosts and peripherals are supported through the USB on the go and embedded host supplement to the USB 3.0 specification. Protocols: the USB on the go and embedded host supplement to the USB 2.0 specification introduced three new communication protocols: Attach Detection Protocol, Session Request Protocol and Host Negotiation Protocol. ADP allows an OTG device, embedded host or USB device to determine attachment status in the absence of power on the USB bus. This enables both insertion-based behavior and the possibility for a device to display attachment status. It does this by periodically measuring the capacitance on the USB port to determine whether there is another device attached, a dangling cable or no cable. When a change in capacitance, large enough to indicate device attachment is detected, then an A device will provide power to the USB bus and look for device connection. A B device will generate SRP and wait for the USB bus to become powered. SRP allows both communicating devices to control when the link's power session is active. In standard USB, only the host is capable of doing so. That allows fine control over the power consumption, which is very important for battery-operated devices such as cameras and mobile phones. The OTG or embedded host can leave the USB link unpowered until the peripheral asks it to start delivering power. OTG and embedded hosts may not have much power to spare from their batteries, and leaving the USB link unpowered helps stretch battery life. HNP allows the two devices to exchange their host peripheral roles, provided both are OTG dual-role devices. By using HNP for reversing host peripheral roles, the USB OTG device is capable of acquiring control of data transfer scheduling. Thus, any OTG device is capable of initiating data transfer over USB OTG bus. The latest version of the supplement also introduced the idea of HNP polling, whereby the device in host role periodically polls the peripheral, during an active session, to determine whether it wishes to become a host. The main purpose of HNP is to accommodate users who have connected the A and B devices in the wrong direction for the task they want to perform. For example, a printer is connected as the A device, but cannot function as a host for a particular camera, since it doesn't understand the camera's representation of print jobs. When that camera knows how to talk to the printer will use HNP to switch to the slave role, making the camera the host to the printer so that the user's pictures will get printed without juggling cables. These new OTG protocols cannot pass through a standard USB hub since they are based on physical electrical signaling. The USB on-the-go and embedded host supplement to the USB 3.0 specification introduces an additional protocol, role swap protocol. This achieves the same purpose as HNP by extending standard mechanisms provided by the USB 3.0 specification. Products following the USB on-the-go and embedded host supplement to the USB 3.0 specification are also required to follow the USB 2.0 supplement in order to maintain backwards compatibility. Superspeed OTG devices are required to support RSP. Superspeed peripheral-capable OTG devices are not required to support RSP since they can only operate at superspeed as a peripheral. They have no superspeed host and so can only role swap using HNP at USB 2.0 data rates. Device roles: USB OTG defines two roles of devices, OTG A device and OTG B device. This terminology defines which side supplies power to the link, and which is initially the host. The OTG A device is a power supplier, and an OTG B device is a power consumer. The default link configuration is that the A device acts as USB host and the B device is a USB peripheral. The host and peripheral modes may be exchanged later by using HNP. Because every OTG controller supports both roles, they are often called dual-role controllers rather than OTG controllers. For integrated circuit designers, an attraction of USB OTG is the ability to get more USB capabilities with fewer gates. A traditional approach includes for controllers, USB high-speed host controller based on EHCI, full low-speed host controller based on OHCI, USB device controller, supporting both high and full speeds, fourth controller to switch the OTG root port between host and device controllers. This means many gates to test and debug. Also, most gadgets must be a host only, or a device only. OTG hardware design merges all of these controllers into one dual-role controller that is somewhat more complex than an individual device controller. Targeted Peripheral List: the Targeted Peripheral List or TPL applies to all targeted hosts, which includes both OTG devices acting in a host role and embedded hosts. The aim of the TPL is for a manufacturer to list products supported by the targeted host in order to define what it needs to support in terms of output power, speeds, protocols and device classes. The TPL is intended such that hosts can be targeted at a particular product or application rather than being forced to be general-purpose hosts like a PC. Plug. OTG mini plugs. The original USB on-the-go standard introduced a plug receptacle called Mini AB, which was replaced by the Micro AB in later revisions. It could accept either a Mini A plug or a Mini B plug. Mini A adapters allowed connection to standard A USB cables, coming from peripherals. The standard OTG cable had a Mini A plug on one side and a Mini B plug on the other. The device that had a Mini A plugged in became an OTG A device, and the one that had Mini B plugged became a B device. The type of plug inserted was detected by the state of the pin ID. OTG microplugs. With the introduction of the USB microplug, a new plug receptacle called Micro AB was also introduced. It can accept either a Micro A plug or a Micro B plug. Micro A adapters allow for connection to standard A plug type USB cables, as used on standard USB 2.0 devices. An OTG product must have a single Micro AB receptacle and no other USB receptacles. The OTG cable has a Micro A plug on one side, and a Micro B plug on the other. OTG adds a fifth pin to the standard USB connector, called the ID pin. The Micro A plug has the ID pin grounded, while the ID in the Micro B plug is floating. The device that has a Micro A plugged in becomes an OTG A device, and the one that has Micro B plugged becomes a B device. The type of the plug inserted is detected by the state of the pin ID. 3 additional ID pin states are defined at the nominal resistance values of 124 key copyright, 68 key copyright, and 36.5 key copyright, with respect to the ground pin. These permit the device to work with the USB accessory charger adapter, which allows the OTG device to be attached to both a charger and another device simultaneously. These 3 states are used in the cases of a charger and either no device or an A device that is not asserting VBUS are attached. The OTG device is allowed to charge and initiate SRP but not connect. A charger and an A device that is asserting VBUS are attached. The OTG device is allowed to charge and connect but not initiate SRP. A charger and a B device are attached. The OTG device is allowed to charge and enter host mode. USB 3.0 introduced a backwards compatible, super speed extension of the Micro AB receptacle and Micro A and Micro B plugs. These contain all of the pins in the USB 2.0 micro and use the ID pin to identify the A device and B device roles. Additionally, they contain the additional super speed pins. Cell phone implementation. BlackBerry 10.2 implements host mode. Nokia has implemented USB OTG in many of their Symbian cell phones such as Nokia N8, C6-01, C7, Oro, E6, E7, X7, 603, 701 and 808 PureView. Some high-end Android phones produced by Samsung and Sony under Xperia series also have it. Android version 3.1 or newer support USB on the go, but not on all devices. OTG microcables. When attached to a PC, an OTG device requires a cable which has a USB standard A plug on one end and a Micro B plug on the other end. In order to attach a peripheral to an OTG device, the peripheral either needs to have a cable ending in a Micro A plug, which is inserted into the OTG device's Micro AB receptacle, or the OTG device itself needs an adapter cable which is a Micro A plug on one end and a standard A receptacle on the other. The adapter cable enables any standard USB peripheral to be attached to an OTG device. In order to attach 2 OTG devices together requires either a cable with a Micro B plug at one end and a Micro A plug at the other, or can be achieved using a combination of the PC cable and adapter cable. Backward compatibility. USB OTG devices are backward compatible with USB 2.0 and will behave as standard USB hosts or devices when connected to standard USB devices. The main exception is that OTG hosts are only required to provide enough power for the product listed on the TPL, which may or may not be enough to connect to a peripheral which is not listed. A powered USB hub may sidestep the issue, if supported, since this will then provide its own power according to either the USB 2.0 or USB 3.0 specifications. Some incompatibilities in both HNP and SRP were introduced between the 1.3 and 2.0 versions of the on-the-go supplement, which may lead to interoperability issues when using these protocols. Charger compatibility. Some devices can charge their battery via their USB port. Others can even detect a dedicated charger and draw more than 500 mAh, which allows them to charge faster. OTG devices are not excluded from either of these options. References. External links, official website, USB on-the-go basics.